Hey, welcome. We made it through about half of Advent of Code last time. Of course, the easiest of the problems. And I thought I would keep going a little bit, so. We'll see how it goes. If I get stumped or annoyed by a problem, I may just stop. Alright. So this one is analyzing the path of falling material. So I have scans that tell me the layout of a cave.
There was a cook who brought a janky indie Metroidvania everywhere she went. She was often known as Ziphoid Mary.
Oh my god. That's truly terrible. That's awful. Alright, so sand is rushing into this cavern following some rules. It always falls down one step if possible. If it's blocked, it tries to fall down one step down and to the left. If that is blocked, then it attempts to move down and to the right. Okay. I think there is a clever way I can solve this. With Python. Rather than actually trying to represent this on a grid, I can represent it sparsely by just a collection of, like, fixed points. So I can just have, you know, a set of fixed points. I can make the walls fixed points, and after sand has settled, I can make it a fixed point, because sand can't move after it's already moved once. Let's read in their input first. Or line in input dot strip dot split lines. So what's going on with a line? Entries. So for entry in line dot split on this sort of arrow symbol here. And then the XY pairs are those values split up. I think I want to put them into a list, so I want to say v equals int x, int y for xy in no, not exactly. So I want to start with v equals x for x in line split. That's just line dot split. And then and then for each one of those, tuple of I want to get the tuple result of int x for x in e dot split on the comma. See what I'm getting here. Okay, yeah, that's giving me what I wanted. Cool. And so now what I want to do is I actually want to pair them off. I can do this with itertools, but it's just as easy for me to do this normally, right? I can just say, for ax, comma, ay, bx, comma, by, in zip of v going up to but not including the last element, and v starting at the second element. So that's a ax, ay, bx, by. So this should pair them off. 5034, 5024, 5024, 5029, 5029. Okay, yeah, that's working. Cool. Alright, so now, if ax equals bx, then this is ranging in the y value. So I will say for y in range from ay up to by plus 1. Fixed dot add ax y. If ay equals by, then it's the same thing but flipping the x's. Yeah. You're not wrong, actually. Is there a more Pythonic way to write this? I don't think it really matters, but... So let's see what's in fixed after I do that. Oh, this is not doing the thing I wanted to do, actually. Bx here. What happens... Okay. What happens if you say range from 3 to 1? It just doesn't exist. Okay. I was wondering if Python did something fancy there I wasn't expecting. Yeah, I kind of expected that to be the case, but I thought maybe Python would be clever about it in some way. Python's built-in complex data type to represent X. Ugh. Representing points in space by using a complex data type feels so dirty. I mean, I guess from a mathematical perspective, it's perfectly fine. There's no meaningful distinction there. It's just kind of weird. Yeah. No, I totally believe it works. I'm just saying I think it's kind of weird. Yeah, I think that's the thing, is that for like a coding challenge solution, it's a really clever idea. From the perspective of writing semantic code, it's woof. Okay. Alright, now I just add sand one at a time. Well, the thing is solutions like that benefit from being able to take advantage of built-in data structures. Like, if you look at solutions that are written by people who do these sorts of coding challenges, they usually have a big boilerplate of code that they always start with, and use that to like speed them up. You know, they've got a whole bunch of code that they've already written and is already useful for them. I don't find that as interesting for my purposes right here where I'm writing code, but I understand why people do that. I came up in that community. I learned a lot from those sorts of coding challenges. I've participated in, you know, USACO, Google Code Jam, ACM ICPC, a lot of different coding competitions, so. Huh? low is my webcam situated? There we go. Oh, does it? I guess that's a good way to make sure that you get your top 10 ranking or whatever. Going pretty good. Yeah, now I'm a coach for the USACO stuff. -1 is considered left. It's like you're definitely going to move down each step, right? Unless there's nowhere to move. Yeah, let me just do it this way then. I'm gonna make it hard trying to... So it tries to go... All 3 possible destinations are block units and comes to rest. Okay, that didn't work. Oh, it's because once it's settled, I didn't put it in fixed. $24. Yeah, just hit me up, Gilder. When the 2 of you are ready to go wild, just let me know. You realize you misread the scan. There isn't an endless void at the bottom of the scan. There's floor, and you're standing on it. You don't have time to scan the floor, so just assume the floor is an infinite horizontal line with y coordinate equal to 2 plus the highest y coordinate of any point in your scan. Hmm. Hey, Carrie, it's going good. I just need to add logic for if it hits that point, it is fixed. Why is that saying 1 now? There we go. Cool. I didn't enjoy that one. Simulation problems are by and large messy, especially when they're designed to be messy. Feel the ground rumble again as the distress signal leads you to a large network of subterranean tunnels. You don't have time to search them all, but you don't need to. Your pack contains a set of deployable sensors that you imagine were originally built to locate lost elves. Sensors are very powerful, but that's okay. Your handheld device indicates you're close enough to the source of the distress signal to use them. You pull the emergency sensor system out of your pack, hit the big button on top, sensors zoom off down the tunnels. Once the sensor finds a spot it thinks will give it a good reading, it attaches itself to a hard surface and begins monitoring for the nearest signal source beacon. Sensors and beacons always exist at integer coordinates. Each sensor knows its own position and can determine the position of a beacon precisely. However, sensors can only lock on the one beacon closest to the sensor as measured by the Manhattan distance, the L1 norm. There's never a tie where two beacons are the same distance to a sensor. None of the detected beacons seem to be producing the distress signal. So you'll need to work out where the distress beacon is by working out where it isn't. For now, keep things simple by counting the positions where a beacon cannot possibly be along just a single row. Okay. Am I what? Am I missing the first line? Oh yeah. Why am I missing the first line? Oh, because it has -2 in it. Thanks. So basically, the way this works is every sensor tells me its closest beacon, which basically blacks out a whole region around it. So every sensor I've marked with basically how large of a region around it in Manhattan distance is empty. The input told me that there's only going to be one beacon that is within that distance. So basically what that tells me is I already know the one beacon that's in that distance, no other beacons can be in that distance. So all I care about is this one target row. So I would say... Um, so that tells me what the distance is between me and that target, or this sensor and that target row. So when I project it, it only expands out a certain distance here. So basically, intervals dot append, I want to add a pair of values, and it'll basically be the x value minus, the width actually is like d minus this. Hold on a second. Or is it that minus d? I think it's d minus this. And so if w is greater than 0, then continue. But I want to add to the intervals x minus w and x plus w. And these are the intervals of coverage in this row. And then I want to sort this. So the idea is when I hit a left endpoint, I figured it was going to do that to me. Let's keep this as checking for nuns. What happens if I compare... Yeah. Okay, so it said negative 53, which is definitely wrong. This time it says 5. So these are the sensors that it believes are close enough to appear at the y equals 10 line. So if it's centered at 2014 with a distance of 8, then projected onto the row yeah, that looks fine to me. No, you pay me to tell me a history fact, Dave. Oh, I actually think I do know what's happening. I need to do this one last time, right? Is that going to be it? Oh, that still isn't it. Okay. I think my code's correct now, but let's find out. And the row it's interested in is... $2 million. Distress beacon is not detected by any sensor, but the distress beacon must have X and Y coordinates no lower than 0 and no larger than 4 million. How do I want to solve this one? If there's only one possible location, that means it has to be right outside the border of one or several sensors, which means I might just be able to check those locations. Right? Because if it were more than just one cell away from the edge of a border, then there would be multiple such locations. It has to be like right outside, I think. I'm gonna go with that theory. Okay, I'm gonna double yield a lot of things, but it's fine. Yo, thanks for the raid, Large Databank. We are solving some advent of code problems. Nice, congrats. So this is a location I know is out of the bounds of this sensor, but I just want to check to see if it's out of the bounds of every sensor. Oh, enumerating them might still be slow because the size of these regions is extremely large, right? Oh, I did get 2 values. It's going to be a very large number. I could just take these numbers and do the math myself, but why would I do that? Okay. Maybe not the most efficient way to solve that problem, but good. Worked. Vice is surrounded by elephants. You must have gotten lost in these tunnels. Need to get the elephants out of here. You have 30 minutes. A network of pipes and pressure release valves. This is technically a, this is technically a time-dependent graph problem. Where you kind of have, like, the idea here is that you have a version of the graph at each time point, and the value of an action is based on which version of the graph you are at which time. That's not a great type of algorithm to have to code up, though. That's not the sort of algorithm I think to myself, love that for me. Do you not like? Some of these just say tunnel and some of them say tunnels. The tunnels leads to vowels. Shut up. Regular expressions are great. Who says they're not? So they're all symmetric. So this is an undirected graph. If this were a directed graph, I might be able to get away with doing like a dynamic programming algorithm. I worry. Well, that I can probably still do dynamic programming, right? I could do dynamic programming. My state would just have to be which valves I've turned on. Using regex to parse HTML only makes sense if you're writing the HTML. I mean, that's the answer. I want to... So I'm trying to think of what my state space would be if I wanted to do dynamic programming. I worry that's more complicated than I'm thinking. Just gotta think about it. The time dependency here is what's really tripping me up on what my state space would be. I just need to think about this one for a minute. So you only have 30 seconds. It's not technically entirely outside the realm of possibility to build a temporal graph here. I mean, it would be possible to do so. Because you would only need 30 copies of the graph, and the graph's what? Couldn't be that big. I mean, how big could graph be, right? Oofta. But oh no, am I gonna build a time-dependent graph? I don't want to. Is that going to be the ideal way to write it? That does give me, to some extent, a... It becomes actually way easier to model. It's just a huge graph. then you just have to build a shortest path or a min cost path implementation. There's like, I know of algorithms that can solve this. I don't want to write them. I do not want to write them. So I can do max cost path using breadth first search on a priority queue. My version of the graph will not contain cycles. It cannot. It's not possible for it to contain a cycle. Which means it's directed and acyclic. Oh, actually, the way I'm thinking of doing this might have an added problem of not being able to maintain state very well. So I would need a separate copy of the graph for every single time I activate a valve, which increases things by a pretty significant factor I wasn't considering. That's not good. Yeah. Okay, so that is not, that's not good. The thing is you're trying to find the most pressure, right? So it would be possible to write sort of an inverted branch and bound algorithm, kind of, right? Like, the basic premise of it would be that you find a solution. You find a solution for some amount, and then you like iterate over all other possible solutions, but you don't have to search in that direction anymore if you realize that at the point in time you're at, you cannot release more pressure than your current best. Which is kind of backwards to the way that you often write branch and bound, but I think it could work. If you adjust your problem, actually, you could write it as a normal branch and bound, right? If you adjust your problem so that you, rather than counting it as pressure released once a valve is turned and you start releasing at that point, if you instead think of it as pressures being released up to a point where you turn the knob, then you can write it as a normal branch and bound, because then you're trying to minimize the number. You would just need to be able to keep your state. I kind of want to just tinker with this one. I don't think I have a solution in mind. I think most of the solutions I've envisioned so far are bad, but I want to tinker with this a little bit. I don't need default dict. What is this song? I recognize it, but I don't know Sega Racing. I don't know enough Outrun music to feel like I know it from there. Did La Mulana 2 use this track and like mix it or something to do something with it? This feels like something I vaguely recognize from La Mulana 2. Anyway. So I want to find the best path. My current best so far. I'm gonna flip the whole problem. Because it's easy for me to find out what the correct solution should be. I'm gonna flip the problem so that the number goes up before the valve has been flipped, because all I have to do is take all of these, multiply them by 30. And that's the inverse, right? So the best I've seen so far, and then where I currently am, well, time, well, score, time, current location, and active. And basically, if at any time my score goes above the best, I don't have to search anymore, I can just stop. So I can naturally branch, or I can naturally bound it. This is such a weird... I don't feel like I'm doing this efficiently, but who cares, whatever. So at... So it takes me a unit of time to move from one location to another, or to flip the valve at a current location. So one thing I can do with my time... If best is if my score has now gone above best, return. I don't need to do anything else. Return best. And then at the very end, what I want to do, like I need to figure out what I'm trying to calculate. B equals best path given a starting... So worst is flow values, get the sum of those, and multiply it by 30. And for the sake of argument, we'll say I'm going to start with worst plus 1. So this is what I would get if I never flip any of the valves, is I would get worst plus 1. Start with a score of 0 at time point 0. I start at location... Where do you start? At AA? Is there an AA in here? Yep. And the active valves are... all of them, right? Is there a way to, like, I'm trying to consolidate this data down so that I'm not passing around such large data structures? Time equals 30, return score. And so now the question is, what am I doing with my time? One option is what I get when I move. For all of the options that involve moving, so that would be all the places I can get to from here. So for destination in tunnels that are attached to my current location, that would be best path given. Still, this is the best I've seen so far. My score is going to go up by all of the valves that are not turned off. So in this case, in this situation, that would be valves minus active. So these are all of the valves that are still active, or still producing flow. And so I want to sum together flow of V for V in valves minus active. That is flow per second. Yeah, Agranosh. But I only need to calculate that one time, and I can subtract off for all of the valve turning options. So, the time would be time plus 1. 1 second has elapsed. My new destination and the same active valves. Nothing's changed in that regard. So these are the options for if S is less than the result. So these are all the options that involve moving. And the option that involves turning the valve it's just plus for is Python set. What's the? Is it just plus to do union? Why is the normal Python documentation not one of the first hits? Just absurd. No. It's pipe for union. I don't want to try to make the leap from this value to this value because I'm going to end up with an issue where if it had already been flipped, then... Actually, I guess I can just say... I can probably be... Hold on, I can be smart about this. If current not inactive. Minus... Wait, I need to make sure I understand. When I take this option to flip it, it doesn't change the FPS yet. Oh, that actually makes my life a little easier. So this is not moving. Is that gonna work? My best attempt at branch and bound, but it might be dreadfully slow. Let me try it for small values of time. Okay, answer's too large. Oh. Oh, it's very slow even for 15 seconds. Oh, that's incredibly slow. Is it possible for me to find myself... Do I want to add memoization to it? Is that the fix? We're trying to release the pressure from the volcano so it doesn't blow up. There's no way this speeds anything up. If anything, I'm just gonna break this. What? Unhashable type set. No, that checks out, yeah. Oh yeah, I can just use Frozen Set, can't I? Oh, I still have it set to 15. Thank you. It's probably been 5 or 6 years since I've wait, I'm still running on the sample input. I'm a doofus. I've been like submitting down here despite the fact I'm running on the sample input because I'm just not even thinking. I bet I'm using a pretty hefty amount of memory right now. Yes, I'm currently using about 7 gigabytes of memory. Oh, nope, it's calming back down to 6. Branch and Bound should have reduced my need for memoization. Okay. Well, all that work and I got the wrong answer. So cool. Oh, I'm not actually doing branch. Hey, everyone. Remember when I said branch and bound? This is not doing branch and bound, which is cool. If you want to do branch and bound, you actually have to bound it. You can't just say the word bound and then hope for the best. Okay, I don't know why it wasn't obvious to me that that was not doing branch and bound, but, hey, guess what? I get the right answer now. Real, we have branch and bound at home energy on that one. The whole point of branch and bound is just don't pursue a path if it can't improve your solution. So, in theory, a larger, more complex data set should be subject to the same bounding. Like, it should cut off still pretty fast. Like, asterisk, relatively. Honestly, if I get an answer back in like 2 minutes, I'll be happy. I'm not going to put up a big fuss about how optimal my solution is. Oh yeah, I know part 2 is going to be potentially worse. Now, one thing I could do, if I wanted to optimize this a little bit, is rank what order it searches for things in. Modifying this code so that when it chooses a destination, it prioritizes choosing a destination where it could go and potentially... I know it might come back with a solution first. I don't care. I actually kind of want to toy with optimizing this a bit. This should happen first, right? This is an act that affects the flow per second more directly. And then ordering these... There. Oops. Let me make sure it's saved before I run. Okay, this seems like maybe the best ordering I can get. I've sorted them by a lambda that prioritizes ones where I could go and change the flow more effectively. If I really wanted to get sweaty with this, I could create a data structure in advance that helps me here to path toward tunnels that lead to valves that need turning. But just in terms of like making the best decisions based on local information, this is maybe the best it gets. Also, my computer's not chugging anymore because I don't have Python memoizing 8 gigabytes worth of information. Python is currently taking 8 megabytes rather than 8 gigabytes. Just store the entire problem space, Forehead. I'm worried that the improvement that this lambda is giving me is marginal when compared to the amount of complexity it's adding. I'd probably get a better speed up if I... Well, this happens right at the very beginning, so... So no, that's not necessary. I still wonder if there's some sort of like, time-dependent shortest path algorithm you could use to do this. Alright, let's put a bub Z in it. It would be the right width if each of these were doubled, I think. I'm starting to have some questions about my solution. It does seem to be taking its time. Well, this is not ideal. What I can do is I can check the active list, and if the active list is all of them, then I can return early. Gilder and Ubergoose. Trying to think if there's some way that I can get it to find a solution that it flips all the valves early, right? Like if I can get it to give me one of those solutions as quickly as possible, that'll give me a decent best that will preclude so many paths. Can I get to bail out any earlier? Trying to think of how I can get to bail out earlier. Like something like, don't let it walk back along the path it just came from. Maybe that's... Weird request. Probably. I mean, I can pre-calculate this to a certain extent. And then I don't have to recalculate it every time. So this won't sort it over and over again, which will be a little bit faster. The thing is, with the amount of recursion that's happening here, any small improvements I can make to each loop is going to make a big difference. But at the end of the day, the best improvement I could make is to order this most effectively. And as it stands right now, it's not obvious to me what I could do. Okay, here's a kind of interesting, but ultimately very dumb idea. How dumb? Is this too dumb? Is this idea going to be too dumb? Here's my idea. The problem is that I only have local information, right? So I want to order the destinations I could go to as effectively as possible. But, like, if I want to get from one valve to another, I may not be able to make the direct jump. So what if my tunnels list weren't a list, but rather a dictionary of how many steps I would have to take to get to any given location? Then, technically, it's all local information. It just takes me that number of time steps to get to that location. That would really speed things up, because then I could make effective decisions based on which locations actually have valves that work for me. I really don't want to do an all pairs shortest path algorithm. I haven't coded... I don't even remember how to do an all pairs shortest path. Oh my god, it's been Floyd Warshall. Holy shit, this brings me back. I haven't thought about the Floyd Warshall algorithm in like 10 years. Holy shit. This is like the dumbest thing I've ever had, like, a weird nostalgic moment for. I'm messing around on 16 still. I'm playing around with optimizing this solution very, very stupidly. Hey, Arton? I'm overdoing my solution for this, I think. But I had a brainwave that I really just kind of want to explore. Yeah, Floyd-Warshall is an n-cubed algorithm, but it's n-cubed on a graph for its vertices, which is typically actually pretty good. An algorithm like this in n-cubed just on the vertices of the graph is solid. Hey, low level learning, thank you so much. Thank you for the raid. So this should... This should be able to be faster. Can you do tuple unpacking in a lambda? Nope. No. Okay, that's gotta be faster. It is. That's not right, though. Okay, let's try the original data set again really quickly. I'm doing 1,000 calculations per second, and they're all wrong! Alright. That's the wrong answer for that. Okay, JJ to HH, it says has a distance of 7. Does that make sense? That does make sense. Oh, this is my issue right here. So don't move somewhere that's going to overshoot. Oh, you're all good? Okay. I think this might give me the right answer. This should have been an optimization. I'm not sure why it seems slower suddenly. Okay, it gave me the right answer again, but it gave it to me with a little bit of attitude, I'll be honest. A little bit of attitude. Theoretically, the very first path it should search is the one that involves going to each valve and shutting it off. I've specifically engineered my solution so that the first path it chooses should be the one that shuts off the flow as early as possible.